Hello and welcome to this session. In this session, we'll be discussing a very important programming technique known as modular programming. Through this session, we'll also discuss some of the concepts related to Python modules and packages. So let's begin. Modular programming is a very common as well as important practice in almost all famous programming languages, and Python is no different. Modular programming is a technique which allows us to break down large programs into smaller and more manageable pieces of codes. Doing so provides us various benefits, such as resulting in simplicity of the code, meaning that any programmer can understand the code with less effort in lesser time. It also aids maintainability. Better maintainability means that the code can be logically managed in the storage space and can also be worked upon by a team of different programmers. Any large program for a specific application may contain few or several smaller sections, where each section contributes something to the complete application. For example, when designing a game, one section of the code may be responsible for providing the graphics to the game. Another section may be responsible for managing the user files. Another may be responsible for logic running in the background. When modularized and maintained properly, different people may work on different sections or modules of the code and then combine these modules together, which will finally result in the complete working of game. Modularizing the program also inspires reusability. For example, one module developed for a game to save the user progress may be used as it is in another game. Hence, the development time and effort will be reduced just because of modular programming. Modular programming also allows us to manage the scope of variable with ease. Functions, module and packages all are concept of modular programming practice. We have already discussed function, and in this session we'll be focusing on modules and packages. In Python, a module is nothing but a Python file with .py extension containing a set of statements. This file may be executed directly just like any other Python program, or may be imported by any other programs or module. As discussed earlier, it helps us to maintain, simplify, and reuse the code. Any module may contain different functions, variables, classes, as well as runnable code. When imported by any other program or module, these functions, variable, classes may be accessed by the calling program or module. There are various ways to use a module in our code. Let's take a look at some of the examples using built-in Python modules. So we have jumped to our Jupyter notebook. One of the built-in Python modules is math module. This offers various maths function and constant, which means that we do not have to define these functions again in our code. We can just import the math module and use the functions it offers. So let's import the math module using the statement import space math. From the math module, let us print the value of pi. To do so, we have written the statement print within brackets math.py. So as you can see here, the value of pi has been printed. Let's now make use of a function offered by the math module. This function is degrees. This function will basically convert any radian value into degrees. So let's make use of this function to convert pi by 2 radians into degrees. So as you can see, the result is 90 degree. Similarly, pi by 4 is 45 degree. Let's use another function to calculate square root of a number, and this function is sqrt. Writing math.sqrt with parameter as 4 will give us the square root of 4. Instead of importing any module directly with its name, we can also import the module but can refer it with some other name. So let's import math but call it just m. The syntax to do so is import math as m. Now that we have imported math as m, we will refer M and call the function of the main module like this. Whether we import the modules with its own name or any other name, its functions are not directly accessible in our code. For example, in order to access the sqrt function, we cannot write sqrt directly. We need to write math.sqrt. But let's say we directly want to access sqrt in our code. We can import the function sqrt itself from the math library. In order to do so, we have to write the statement from math import sqrt. Now we can directly write sqrt 16 and the result will be printed as if it was a function defined in our code. Similarly, we can also import pi in our local code and directly print the value of pi like this. Let's say you want to import all such constituent of the module into your code. You may write from math import star. The asterisk here basically means that we want to import each and every function of variable from the math library to our code in order to directly use it. Just like the math module as shown in this notebook, there are many other inbuilt modules such as time, OS, sys, etc. And apart from the built-in modules, the programmer can create custom modules as well. And these are called user-defined modules. Let's try to create a simple module. So here we are in our Jupyter Explorer. Let's create a new Python notebook and rename it as custom. So here we have defined a new variable named var and a new function called new_func, which accepts two numbers and returns their product. Let's go to File, select the Download as option and select the Python option and save it in our project directory as custom.py. You can give it any name you like, but the same name should be used when you import this as a module. Let's now go to our previous notebook file and import the newly created module. Once imported, we can write the statement custom.var to print the value of variable defined in the custom module. As you can see, the value has been printed. We can also use the function new_func to multiply 2 and 4 and the result has been printed as shown here. So this was an example to create a simple custom module and how to use it in another program. For any module, inbuilt or user defined, you may check the available variables or functions using the dir function. The dir function will accept the module name as the parameter and print the constituent of the module in an alphabetical manner. As you can see here, I have used the dir function to check the offerings of math function and a complete list of functions and variables have been printed. Similarly, we can do the same thing for our custom module. Now let's understand how Python looks for the module when you import it. Basically, when any module is interpreted, Python searches it in 3 locations. The first location is the directory from which our code is being executed. If Python finds the module in this directly, the import will be done immediately. In case it fails to find the package in the working directory, the search will move on to all the directories mentioned in the Python path environment variable. If found, the import will be done, but in case the module is still not found, the final search will be done in the default directory, such as the installation directory. But the default directory may vary operating system to operating system. Now that we have understood what are modules, let's try to understand that what The concept of packages in Python is similar to the folder structure of file system on an operating system. Just like we organize one type of files in one folder or directory, similarly multiple modules of similar type may be contained by a package. And just like a folder may contain subfolders on our operating systems, a package may also contain subpackages. Here we have illustrated a package with this diagram. The package has been named test_package and it contains three modules. Modules_1.py, module_2.py, and module_3.py. As you may notice, the test package also contains another Python file name init.py. This is a special file which may be empty but must be contained in the package. So assume that we had to use one of the modules from this package, let's say module_2.py. The statement to do so would have been from test_package import module_2. Further, any function or variables from the module_2 can be used just like we saw in case of modules. There are many Python packages which are very commonly used. Some of them are OpenCV, which is used for image processing application, sklearn, which is used for machine learning application, matplotlib, which is used for plotting data. You may create your own packages and modules to practice, and you may also explore about various built-in Python modules. So that's all in